Alright, y'all, it's time for, believe it or not, the last video of the whole year for Algebra 2. It's been a doozy. So let's get started. This last video is reviewing what is going to be crucial from first semester for this final, which I also tried, everything we learn in this class is important, but I also tried to pick the things that are going to be most crucial for your math class next year. So what we started with in Unit 1 was describing different features of functions. So we talked about intercepts. So on this graph, my x-intercept, I only have one, would be at -2, 0. My y-intercept is at 0, 3. A relative max means basically a hill when I'm comparing to the left and to the right. This graph actually doesn't have a relative maximum. There's not a point that's higher than everything to the left, or not everything, but immediately to the left, immediately to the right. But I do have a relative min right here at the point 4, 1. All right, so now we're going to go from talking about points to talking about intervals. So let's talk about increasing. So increasing is where it's going up from left to right. The other thing we did before we started writing, all of these are intervals, and we only use the x values. So one thing we talked about was kind of writing coordinates. So this is going left and down. So negative infinity, negative infinity. I have my key point of an x-intercept. I have here 0, 3. I have 2, 3. Have something interesting going on there. I have 4, 1. And then I have positive infinity, positive infinity. And when I'm doing intervals, we are only caring about the x values. So we say bye, Felicia, to all my y values. Okay, so increasing. I'm going up from left to right. So negative infinity to 0. Union, it also is going up from 4 to positive infinity. Decreasing means I'm going down. So I'm going down from an x-coordinate of 2 to an x-coordinate of 4. I'm not asking from what height am I going down and how low am I going. I'm saying where is it going down, period. And then constant is going flat, and that goes from 0 to 2. Okay, so what's important here are my x values. And I ran out of colors, but that's okay. So positive means I'm above the x-axis. Well, this whole thing is above the x-axis. So from, oops, that's a -2, y'all, plus. Okay, from -2 to infinity is positive, and then negative infinity to 2, -2, I keep dropping my negatives, to -2 is negative. Okay? So what was the most important thing about the bottom? We're only using x values, okay? After that, we looked at factoring, okay? And we do a lot of factoring, like we've done a lot of factoring with the x and difference of squares and stuff. So I tried to put the other factoring that's probably gone by the wayside. So the first thing any factoring problem we need to do is look for a GCF. So this first one has a GCF. So we need to take out a 2, which would leave me with 2x cubed minus 5x squared minus 6x plus 15. So I'm going to bring down my 2. And when I have 4 terms, most missed question on the midterm right here, y'all, was first term, first box, last term, last box, and then we put the other 2 wherever. Okay, and then we factor out our GCFs. You know how to do this. Okay, so the GCF of my first row is x squared. What times x squared is 2x cubed? 2x. What times x squared is -5x squared? -5. What times 2x is -6x? -3. So that factors to x squared minus 3 times 2x minus 5. Ooh, that got ugly. Even my stylus is tired at this time of the year. All right, there we go. So y'all are really tempted with this next one to just do the x and call it a day. But when I have something in front of the x squared, and it's not a GCF, then that means I need to do x box. So that was where we said a is 4, b is negative 8, c is negative 5. First term, first box. Last term, last box. And we multiplied those and got negative 20. So what two things multiply to negative 20? B goes at the bottom, and add to negative 8. That's negative 10, positive 2. So negative 10x, positive 2x. And we take out our GCF. So that would be 2x. What times 2x is 4x squared? 2x. What times 2x is negative 10x? Negative 5. And what times 2x is 2x? 1. So this one factors to side, 2x plus 1, times top, 2x minus 5. I guess I was really thinking about 2x minus 5 when I wrote these problems. Funny how that happens. Okay. After we talked about factoring, we looked at different ways of solving quadratics. So one method we looked at was solving by completing the square, which you've seen with conics why maybe I made a big deal about completing the square. And in the big scheme of your life, is solving by completing the square super important? Not entirely, but it does show up on standardized tests as a thing, so I do want to keep it in your mind. So for completing the square, you want to move your constant to the other side, which is done for me in this problem. Then we're going to draw a literal square. First term, first box. I want a square, so I need the sides to be the same, so we split in half. Okay, this part seems familiar from our last unit. So x plus 4 squared, but what did I add to this? I added 16, and I'm doing that on the left-hand side of the equation, which means I also need to do it on the right-hand side of my equation. So add 16. Hopefully I get nice numbers here. So that would give me negative 14. And now to finish solving, we're going to square root both sides. Don't forget your plus or minus. So x plus 4 equals plus or minus square root of 14i. And then we add, subtract, since it's addition, our 4 over. So negative 4 plus or minus square root of 14i. Completing the square is happy to do when I have a 1x squared and then an even number in front of my x. Quadratic formula is happy in other situations. This one would be decent for quadratic formula. Or sorry, for completing the square. But we'll do quadratic formula because that's what it's telling me to do. So my first step for quadratic formula is to get everything equal to 0. And it needs to be in standard form, which means it goes x squared, x constant. So a here would be 1, b would be 2, and c would be 2. And we sing our quadratic formula song. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. All right, x equals negative 2 plus or minus the square root of 4 minus 8 would be negative 4. Oh, I wrote a decent problem. Over 2. All right. So simplify, I get x equals negative 2 plus or minus the square root of negative 4 is going to be 2i over 2, and everything is divisible by 2, so this is going to simplify to negative 1 plus or minus I. That was a really weird I, but we'll go with it. After quadratics, we went into polynomials, and we learned about how to divide. So dividing is when we know the side of the box, and we're trying to get to the top. So 3b plus 7. So first term, first box. and we put the divisor, what we're dividing by, on the side. So what times 3b is 3b cubed, b squared, which would be 7 times b squared would be 7b squared. But I don't want 7b squared, I want negative 14. So I need to take away 21b squared. What times 3b is negative 21b squared? Negative 7b. Negative 7b times positive 7b gives me negative 49b. That's a 9, y'all. That's okay. If I don't want negative 49, I want negative 22, so I need to add 27b. What times 3b is 27b? 9. 9 times 7 is 63, but I don't want 63. I want 70, so I need to add 7. So my remainder would be 7 on this problem. So b squared minus 7b plus 9 plus 7 over, you put what you divided by, 3b plus 7. All right. The next one is kind of like an easier version of what we did this semester, but there were a lot of questions on that multiple choice test y'all did where you missed something like this, so I want to make sure that we talk about it, because this should be easy peasy. Okay, which is when I just say f of negative 3 and I give you a function, what does that mean? It means I plug in negative 3 for x. So in this problem, f of negative 3 would be 4 times negative 3 minus 7. So negative 12 minus 7, which would be negative 19. No big deal, right? Okay, that's slightly different from if instead I said f of x equals negative 3. Notice now I have f of x. I have f of x. Guess what? Those are exactly the same. What does same mean in math? It means equal. So I could say 4x minus 7 equals negative 3, and we're going to solve that equation. So 4x equals 4 and x equals 1. Did I get the same answer? No. So even though they look really similar, you have to be able to tell the difference between these two types of problems. F of x is just meaning when I have an input of x. So in this case, we're replacing an input of x with negative 3. On the right, it's saying for what input x will I get out negative 3, okay? So I just wanted to hit on that since that's a pretty crucial understanding for us, okay? Then we had our unit with all of the big fractions. Those are called rationals. And we learned factor, 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 factor. We did so much factoring. And we eventually got pretty good at these type of problems right here, but I just wanted to review it. So first of all, when we're multiplying, we're just going to factor all the things and see what reduces. If it was dividing, I would need to change it to multiplication and flip my second fraction. But since it's multiplication, we're good where we are. So now let's look at factoring. So my first numerator has a GCF of 3, so this would be 3x minus 3. I'm also going to look real quick at my bottom right denominator. That's a difference of squares, so x plus 5, x minus 5. And then the other two I can do in x, so what multiplies to negative 15 adds to 2. That would be 5 and negative 3. So x plus 5, x minus 3. And then this other one multiplies to negative 20, adds to negative 1. That's going to be x minus 5, x plus 4. You want to make sure that your signs are right on these because some of y'all are getting sloppy with the x's at this point and switching these signs. I know why. It's because we've done so many solving problems that when you solve, it's flipping the signs. But especially as we go back, make sure those are the signs coming down to my factored form because that's going to totally change my answer. All right. So as I'm looking, do I have an x minus 3 in the top and bottom? No. Do I have an x plus 5 in the top and bottom? Yes. how about, we already did x minus 3. So this one actually doesn't simplify a whole lot. I feel like it should be a division problem because I feel like that would make life happier. But it's definitely multiplication, so we're going to go with it. Here we go. So I have 3 times x minus 3 times x minus 3. So I'm just going to say x minus 3 squared because I feel like being lazy. It's May. And then x plus 4 times x minus 5 squared. So not everything always reduces happily. Okay, it doesn't mean you did something wrong. It's just that's how life is sometimes. All right. Then our really favorite thing from the fall was graphs of rational functions. So what we talked about doing first was looking at our horizontal asymptotes, which had to do with our biggest exponent. So right now I have the top, the numerator, has a higher degree, which means that there's going to be no horizontal asymptote for this. We looked at it another way of looking at the term with the highest exponent, and so we would do x cubed over 3x squared, and then that would reduce to x over 3, and as x goes to infinity, this is just going to go to infinity. It's not going to a specific number. It's just some really big number divided by 3, and another really big number divided by 3. It's just getting big, 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 big. So there's no horizontal asymptote. And that line of thinking helped for some of you. Others of you wanted to have a specific rule where if the degree of the top is greater than the degree of the bottom, there's no horizontal asymptote. So whether you want to memorize the rule or kind of think in terms of your most important term on the top and bottom, that's totally fine. The next thing we did was look for my y-intercept. So a y-intercept means that my x value is 0. So coming up to the top, I have 0 cubed minus 9 times 0 over 0 minus 9. I got lazy there. So the top is 0, the bottom is negative 9, so my y-intercept here is 0. But, if I put just another little x right here, there would be no y-intercept because I'd get 0 over 0, okay, which was one of those little situations. There's so many different situations with these graphs. I just chose one that we could do a lot of stuff with. But remember, there were all those little caveats and stuff, so you want to really think about what makes sense. It's a hard thing. All right, both of these have a GCF, so I'm going to start with taking out a GCF. So the top has an x, and then leaves me with x squared minus 9. Bottom has a GCF of 3, and then I get x squared minus 2x. 2x minus 3. Okay, now I'm going to keep factoring. The top is going to be x plus 3, x minus 3. The bottom, we need to leave the 3 and then do an x. So it multiplies to negative 3, adds to negative 2. That would be negative 3 and 1. Okie dokie. So up next, once you factor, is we have to see if there's a whole. A whole means you have the same factor in the numerator and the denominator. So in this case, I have an x minus 3 in the top and the bottom, which means my whole happens when x equals 3, because 3 minus 3 gives me 0, which is going to give me 0 on the top and the bottom. So now, once I see that I have a whole, I have to find the coordinates of that whole. So I'm going to write what I had left, which is x times x plus 3 over 3 times x plus 1. To find the y-coordinate of my whole, I'm going to plug in the x value I found, which was 3, in for x. So 3 times 3 plus 3 over 3 times 3 plus 1. So that would be 3 times 6 over 3 times 4, which is going to be 18 over 12, which is 3 over 2. Yes, there was a shorter way to do that. If you saw it, awesome. If not, it's the long way for us. 3 over 2. It's really important that you plug it in after you have crossed off your hole. Otherwise, you're just going to get 0 over 0. The whole point is that you have a hole there. So you have to plug it in after you've crossed off the hole. And now I'm going to pay attention to what I have left. So whatever is left in the numerator equal to 0 is x-intercepts, and whatever is left equal to 0 in the bottom is going to be a vertical asymptote. So x times x plus 3 equals 0. These are my x-intercepts. So x can be 0, or x can be negative 3. So I have two x-intercepts, 0 and negative 3. Then set what's in our denominator equal to 0. And these are my vertical asymptotes. So 3 times x plus 1 equals 0. Well, 3 doesn't equal 0. X can equal 0. 3 can't equal 0. And x equals negative 1. Remember, a vertical asymptote is an equation, so you have to have the x equals part right there. Whew. All right, that's a wrap.